Good morning, everybody. Welcome. First things first, let's do a quiz. Okay? So, you're not going to write down anything. You're just going to talk to each other. Here's some sample questions. Turn to each other, ask these questions. I'm going to give you 5 minutes. Go!
My name's Brandon. Nice to meet you. Nice to meet you. I hope it's not too awkward.
Good morning. Good morning. All right. Question for you. I haven't even introduced myself yet. Why would I have you talk to each other for the first 4.5 minutes of class? Get used to people around you? Yeah, because we're all like anti-social scientists, pre-med types, right? We're not. Yeah. But,
The coffee hasn't quite settled in yet.
right, yeah, you guys need to wake up, right? You're not my 8 o'clock class. They look dead.
Well, they might.
No, they're not. Okay, we're good. No, okay, so these are good guesses. They are incorrect answers, but first lesson, do not be afraid of being wrong, right? Just strong and wrong. That's the motto.
To give the late people a chance to be late.
Oh, yeah, because parking is so bad, right? That's a good idea, but how is the parking?
It wasn't bad, actually.
Not too bad? Is the parking garage almost full now? Yeah, give it 2 weeks. It won't be bad. But yeah, it seems like if you're coming here first, like the parking around here seems to be pretty good, right? Parking over on the main part of campus is pretty bad. But no, it's not for the late people. Any other ideas? Yeah?
Our new partners for the semester.
You're going to need help from people? More on that later. But yeah, no, that's not the reason either. These are all good. I mean, they're good answers. They're good reasons. They're good side effects, I guess. But that's not the reason I had you do it. Go ahead. Keep guessing. It's all right. This is physics class, right? I mean, you know how this is supposed to roll. You're supposed to come in, and I'm supposed to have a 40-minute conversation with the board. Right? Never once turning around, but just putting tons of math all over the place, right? And then sometime about 40, 45 minutes in, somebody will get the courage to ask a question. And I'll be like over here talking to the board, and somebody will go, Mr. Bailey, I got a question. And I'll turn around and in shock and awe that there's still anybody left in the room, and that you would have the audacity to ask me a question. That's how physics is supposed to go, right? Socialize? Why would I want you guys talking to each other for the first 5 minutes of class?
Because the wall is sick of listening.
Yeah, the wall doesn't pay attention to me anymore. No? Let me give you a clue. How do you know when you know something?
When you're able to share it with someone.
I'm going to use a different word than you used. You said share. I'm going to use the word teach. When you can teach somebody else what's in your head, now you know something. So this class is going to be really easy. I'm going to sit out there. You're going to come up here. You're going to teach the class. No, it's not going to happen either. But why? If teaching each other is important, and this is one of our ways to learning, why would I have you talk to each other the very first thing? How many of you have ever had a class or a teacher on the first day of class tell you how interactive their class is and never once interact with you? What was the first thing you did in my class? You talked to each other. Not me. I'm not the important person in the room, even though it's all focused here, right? You're the important person in the room. And if I say that we're going to be interactive and I'm going to have you talking to each other a lot, do you believe me?
Yes.
Yeah, we'll say anything to get an A, Mr. Balogh. Why do you believe me? The very first thing. Hi, I'm Mr. Balogh. I teach physics. I have a lot of fun. All right. I want to know some of these things about youth. Birthplaces, shout them out. Where were you born? Okay, get that one out of the way. Irvine? Okay. San Diego. Get all the sands out of the way. San Clemente, anyone? Okay. Philippines. Tagalog ka ba? Ayos. I lived in the Philippines for 2 years. It's not a contest, but can anybody beat the Philippines? No Africa, no Middle East. Yeah, I don't blame you in the current administration for not wanting to say. Right? This is a safe place. You were totally safe here, right? Fresno City College is it's amazing. I love it, right? It is so cool. We have so many people from so many different places, and I just think it's amazing. What's your favorite thing to do? Like, if you get some time to yourself and you have no responsibilities, what do you like to do? Eat. Run? Yeah? Okay. Did I hear travel? What?
I create new headaches for
Awesome. Stick it to the man. Food challenges? So like consuming the food or making the, oh, consuming the food. Ooh. So you're going to give, what's that guy? Joey Chestnut a run for his money? Yeah. Okay, yeah. Joey Chestnut is the all-time hot dog eating champion. And it's like disgusting amount of hot dogs in 10 minutes. So, what else?
Botany.
Botany. Like Mart Watney on Mars.
Hiking.
Yeah, hiking. Okay. Being outdoors. Video games? Yeah? Movies? Yeah? It's all good things. Were there any good movies this semester or this summer? Dinner was good. I didn't see that one.
The new Superman was pretty cool.
All right. Maybe you can decide to drop the course after I'm about to say what I'm about to say. I did not like the new Superman. I don't think it was a bad movie. It was entertaining. It was a decent treatment of the character, all that kind of stuff. It just wasn't a good movie. Like there were choices made that I didn't like, in particular the way they characterized his Earth parents. Anyway, there were some things about it where it was rough around the edges in terms of the presentation of the movie. I thought James Gunn was okay, but he was much better at Guardians of the Galaxy than he was at Superman. Fantastic Four. It was okay, right? I did like Fantastic Four more than I liked Superman, like as a movie, right? As a visual experience. It thankfully broke the curse of Fantastic Four movies, because all Fantastic Four movies have just been garbage, right? So that was good. Mission Impossible was okay. It's just kind of a bunch of okay movies, right? What was my review for Mission Impossible? It was one line. It was, Mission Impossible is a bad movie that was told really well. Like the way they told the story was very creative and interesting, but the story itself was dumb.
So like Tom Cruise's interview.
Right. Okay. It was very much a movie for Tom Cruise to do a bunch of stunts, so therefore plot was non-existent, right? But the way they did it, right? The visual storytelling, the way they unfolded the story, and the fact that it was a love letter to all the previous Mission Impossible movies, I thought was pretty fun. Okay, so what's your favorite place to eat in Fresno that's not your mother or your grandmother's house? Because I'm not allowed to go there.
Vibes Lounge.
What is it? Vibes Lounge?
Yeah. It's in Tower.
I don't know that one. Vibes Lounge. Where else? Anesso's. Anesso. The pizzeria, right? Where else? What?
Pismo's.
Pismo's. Where else?
That Mega Tex barbecue spot.
Where?
I think it's called like Mega Texas Barbecue or something like that on Butler and Orange.
Butler and Orange, Mega Texas barbecue. Why am I writing these down?
Because you're hungry.
I need date ideas from my wife. I need you guys to make me look good. Like I will come home. She doesn't ask me how the first day went. She's like, what did your students say? Where are we going to eat?
The Annex is a winner.
Annex?
Yeah.
I don't think we've been there yet. And that was Mega Texas, right?
That or like Mega Tex.
Okay, but autocorrect said megaton. Right. Annex. Anywhere else? Spell it. T-S-U-K-A-J-I. Okay. And don't autocorrect that one. Okay, thank you. If you come up with any more, let me know.
Vintage Press.
Vintage Press, where they don't put books.
It's in Vicedale.
That's okay. All right, excellent. You guys were good this year. A lot of people just say like Doghouse Grill. And all right. Why are you here? Yeah, because somebody told you had to be here, right? Nobody woke up this morning and went, yes, physics, yeah. Because if you did that, you're in the wrong class, right? You need to be in physics 4A. That's the one for physics majors, right? Okay. This class is primarily designed for like biology, life science, pre-med, technical majors, that kind of stuff, computer science, some other, depends on where you're going. But like the difference between physics 2 and physics 4 is a matter of math prerequisites, really, and intent for where we're going. So I understand. I know that I have a captive audience, okay? And somehow we tricked you into paying to be here. Double crime. But I know why you're here. But what's the future hold? Like, what are your sort of plans? Raise your hand if you are a pre-med major of some kind. Yeah, okay. So botany, bio, sort of life science kind of thing. What else have I got there? Kinesiology majors. Yeah, so like going into maybe DPT kind of programs. So you guys are going to be in school for the rest of your life. What else? What have I missed? Math, okay. Sometimes you have to take 4A. Okay, just making sure. Then we need to talk again. Just to make sure you're in the right spot. Geology. Some geology majors, again, have to take the 4 series. The science majors get a little bit squirrely depending on where you're going. So, architecture, that's a common one for the 2 series. What else? Computer science. Yeah, again, depending on where you're going, Fresno State does the 2 series.
Construction management?
Yes. Anybody else? Counting. Any French literature majors out there? Good. All right. We're in good shape. All right. What are some things in your classes that have really like helped you? Things that you've seen other teachers do that connected with you or helped you succeed in some way? Yeah. I hate what I do. And I hate my students. No, I mean, I like, you'll see. You'll probably ask me to dial the passion back just a little bit. But yeah, no, I like to think that I am that. Yeah. Cheap classroom materials. I am sorry for the book. But everything else, you don't have to pay for like goggles or lab coats, or I give you the lab packets. You don't have to pay those, but I do stick you for the book and its associated systems. We'll talk more about that tomorrow. Sure. Any other things that teachers? Come on, this is how I spy on the other teachers. I never get to go to their classes, so you need to help me here. All right, what are some things that your other teachers have done that you're just like, oh, I wish every other teacher did that too?
They kind of get more in depth of what they're talking about. Like they would add more stuff. They like realize, when it comes to this, but there's also like a different way you can do this.
Different bringing in some of themselves, or at least making, like what I try to do is I try to connect it to like, not your lives, so to speak, but like your educational plans, your interests, right? If I know I got a lot of video gamers in the room, I like more of my examples become video gaming. Like, just kind of get those hooks into your brain, right? So be sure to communicate with me if there's something that you would like me to do. Just ask. I might say no, but like it doesn't hurt, right? To just ask. Okay. So I ask these questions of you. You get 5 minutes to ask me anything you want. It can be from that previous list or any other thing. For the next 5 minutes, I will answer honestly to the best of my ability. Yes?
Do you own a bunch of bow ties?
I do.
Like,
These are all self-tied bow ties. I have one cheater that I don't wear. But yeah, I tie my own bow ties. And by the way, it's the only time you will see me in a bow tie unless there's a funeral, a wedding, or Sunday at church. Yeah. I went to college at Brigham Young University in Provo, Utah. Prior to that, I was at Cabrillo Community College over on the coast. I grew up in Santa Cruz. And so I did 3 semesters at Cabrillo Community College, went on a mission for 2 years to the Philippines, And then when I came back, I transferred to Brigham Young University. Got my bachelor's there and then did my master's there. And on my way to a PhD, I got a JOB. Right here. So I am not a doctor. You may call me master. No, Mr. Bale's fine. Yeah?
Can you tell us more on that story of how you met your wife?
Oh, so you read the... so my wife and I met in Yosemite National Park. I was a ranger intern. I had grown up in Yosemite National Park in the summer times. My father was a ranger in the summer times. He was a community college professor in the wintertime. I wonder where I got that from. And he was a ranger in the summer. So I had been up there every summer from the time I was, I think, 24 days old, 22 days old. And then my wife and her family, they had a cabin up there near the park. And we managed to cross paths when she was 16 and a half and I had just turned 18. So it's not what you think. I thought she was 12, so I wasn't paying attention to her at all, right? But I found out later that she was a little bit older than she looked. We got a lot of really weird looks when we had our first child. Walking down the mall, hand in hand, people would go. Because she looked 14. Just tiny, thin. But yeah, we met in Yosemite. Our relationship survived me being in the Philippines for 2 years. And we got married about a year after I got home. Thanks for asking. Yeah?
What projects do you work on outside?
Outside of my job or outside of class?
Sure.
Okay. So I spend a lot of time, if I'm not in the classroom, I'm spending a lot of time trying to, I research and I study physics education. Okay, there's a whole branch of physics called physics education research that I'm involved in. So we're trying new things, trying to figure out how to make it work for you guys. I have a lot of projects that involve technology. In a former life, meaning when I was in college, I did IT work for the college I was at and supported faculty and staff with all the computing needs from end user workstations all the way through servers and stuff like that. So I am often like working in the engineering department, helping them set up their 3D printers and doing all that kind of stuff. Outside of work, my projects have fallen by the wayside because my health has gotten bad. You'll learn this about me. I have arthritis in my cervical and lumbar spine. And right now I cannot really feel my left foot. And so right now a lot of the projects have been curtailed simply because I can't trust that my body isn't going to go wibbly on me. But if I'm doing something, it's like working in the yard, trying to keep the house from falling down. My wife's cabin up in the mountains always needs attention. So I turn into a carpenter, plumber, all those different kinds of things. So.
Like die inside if you see the CIT 15.
Yeah, no, I know. Yeah. So, anything else? Yeah.
What's your favorite kind of food?
This is such an unfair question. Would you please narrow it down to a culture?
Favorite kind of, let's say,
Chinese
Chinese food?
food is going to be basically any kind of stir fry that's got a lot of vegetables in it. I'm really fond of more authentic Chinese stir fries. Noodles, veggies, and the meat is it's not like broccoli beef where it's beef and a little bit of broccoli. I like it the other way around. My wife and I have a shared hobby and it's cooking. And so just about every day, that we can swing it, we'll be in the kitchen together cooking dinner. I'm more of the entree chef. She's more of the baker and the dessert chef. But kind of explains a little bit. It's right. No, and so we've been, for the last 3 years, we've been attempting Indian cuisine. By attempting, let me qualify that, neither of us have an Indian grandma. What we need is an Indian grandma, right? We need somebody to hit us with wooden spoons when we're doing it wrong in the kitchen. That's how I learned how to cook Italian from my grandmother. But we're doing the best that we can. My wife turns 50 this year, and for her 50th birthday, in the 50 days leading up to her birthday, I'm giving her a present, a very tiny present. And each present is like an ingredient from somewhere in the world. So like I've given her guava paste from Brazil, and I've given her sumac from India. You know, just and so it's a little bit, right, in our house right now, it's a little bit like Iron Chef, right? She has to open the present in the morning, and she's like, okay, this is my ingredient, I'm going to do something with it. So we're having fun. We're having fun. Oftentimes I wonder if my students kind of see me like this, right? Okay, probably more like this. But one of the things you need to understand, and I believe this, okay, or other students have accused me of this too, but I'm none of that. One of the things that you need to understand is my take, my belief, my paradigm, if you will, for teaching, is that it is you and me versus physics. It is not you versus me. Who is responsible for your learning? You are, right? The responsibility rests on your shoulders for learning the material. So what's my job?
To learn the material.
I'm support, right? I don't have to learn the stuff. I've learned it. I'm done, right? I've made it. I have my sheepskin, right? I'm here for you. I'm support for you. And I will bend over backwards and move heaven and earth to try to help you in your learning process, okay? So there's really only one time where I feel it's my duty to judge you and or like it's me versus you. And what's that one time? It's the exams. Like there comes a time when we just have to find out what you've learned, right? And so on that day, I'm still nice, but it's like you'll ask me a physics question, I'll be like, I can't tell you, right? Okay, but every time else, it's you and me versus physics. So if you can kind of get that into your brain, right, that I'm on your side, I've got your back, I need you to have mine because I make mistakes and there'll be something wrong on Canvas and you'll need to let me know. Just don't assume somebody else has let me know, right? If we have each other's backs, you'll be all right. Okay. All right. The big stop recording thing up here is because I now have to do the ritualistic butchering of the names. Go. Oh, always put reminders in. Okay. What I've got to do now, unfortunately, okay, so I just told you how interactive the class is going to be and all that kind of stuff. One of the other ritualistic things we got to do, otherwise students don't feel good, is if we don't talk about the syllabus or something like that, they get freaked out, okay? I have to dump a lot of information on you, and I've not been able to ever figure out how to make it interactive. It's not like I can say, turn to each other and tell each other Mr. Balogh's philosophy for lab. So I apologize for the amount of talking you're going to hear today and tomorrow, right? When we get into Thursday, it'll be a little bit more interactive. So, but I am going to offload till tomorrow text attendance and homework. I want to have more time when we're together in lab to talk about those workflows, okay? Just the very short version is, yes, you're required to pay for the book, and it's through Canvas. It's called Wiley Plus, but do not go to wileyplus.com. It won't work, okay? You're going to sign up through Canvas, and away you'll go. And again, I'm going to show you things tomorrow. We'll go over your options, all that kind of stuff, if you haven't done it already. So let's talk exams, okay? Because everybody wants to know about exams. Okay, I use the C word. What's the C word? Comprehensive. Here's something you need to understand about physics. I can't not make it comprehensive. In other words, unlike other subjects like, I don't know, history or English or philosophy or something, you could, I'm sure there's a best way to teach history, right? I don't know if it's in order or by topic, whatever. I'm not an expert there. But you can learn history out of order, right? It's possible. You can't do that in physics. Everything we do in the first chapter, we use in all the subsequent chapters. Second chapter, third chapter, we're going to be using that in chapters that come afterwards. Physics, chemistry, math, all of these things, it's like climbing a ladder. You have to hit all the rungs. And if you miss a step, you risk falling, right? So it's not like I can turn off Newton's laws, right, when we're talking about momentum and energy. The universe isn't built that way, okay? I will laser focus the exams on the unit that we are in. In other words, first unit is projectile motion and kinematics, how things move, right? The second unit is Newton's laws. I'm not going to go out of my way to ask a question from chapter 3 when unit 2 is on chapters 4, 5, and 6. I won't do that on purpose, but there are elements of the first unit that must carry over into the second. And so in that sense, it's comprehensive. But you will not take a final exam in this course that contains all the chapter's content. The last exam is the 5th unit. Does that make sense? I can't divorce, right, all of the different ideas in physics from each other because they build on one another. But what I can do is make sure that if I'm giving you an exam on momentum, that it's about momentum, right? And not necessarily about projectile motion, even though you might need a little bit of understanding of that to be able to contextualize what's going on. So it's comprehensive by nature, not on purpose. If that I don't know if that makes any sense. You'll get a feel for what that is. Anybody know what size piece of paper that is? Standard 8.5 by 11. Okay, stupid unit system. I'm using the perfect unit system here, right? Okay. We'll talk more about exams, what's on them, all that sort of stuff, what your summary sheet, I call it a cheat sheet sometimes, I probably shouldn't call it that, right? But like that's a summary page that you're going to bring in with you, whatever you want on that page, right, that makes you feel comfortable during the exam. Homework problems, examples, formulas, positive affirmations, whatever it is you want, okay, on that sheet. That's your sheet, not mine. But you get to bring that in with you to the exam. And we'll talk more about sort of the format and what's expected of you and all that kind of stuff. We'll get a little bit into it tomorrow. But just know that there are 5 units in the course. There's 5 exams. I don't drop an exam. I'm not kicking out a whole topic's worth of physics just for your grade. Okay? Again, it builds, and we need to make sure it's building properly. There is a very scary number on this screen. 65? 65! Mr. Balogh, I don't take tests well. They scare me. All that could be true. But it is not the most important number on the screen. The 20% of homework is the most important number on the screen. Because that's where like 98% of the learning is going to take place. Okay? Homework is really where the rubber meets the road in this class. And I am entirely confident in saying that if you are proficient in homework, I don't expect mastery. I'm a master. Master's degree. Proficiency though, right? Being able to work through the problems and understand the physics and apply it correctly, right? That's all practice you're going to get during homework. And one of the things you're going to learn in here is that failure is always an option. Matter of fact, failure is the rule. I want you to get all the failures, as many failures out of your system as possible before we get to the exam. So you're going to feel beat up in here. You're going to come to lab, just beat us up all day long, told us how wrong we were, okay? How many of you have heard of the scientific method? Yeah, what's the scientific method?
Try, fail, and try again.
I like that. Try, fail, and try again. It's not hypothesis and experiment, whatever that list is. I hate that list, okay? That is not the scientific method. Scientific method is fail. Fail rapidly, right? Fail as fast as you can, each time changing a little bit, right? Try something, it doesn't work, tweak it, try it again. Keep doing that. Don't give up. Successful scientists are not smart. They're stubborn, right? They just won't let it go, right? But they're also open to changing their minds, right? There's a flexibility implied there in the scientific method that's very important. So I am going to give you so many chances to fail in here. Failing on quizzes, failing on your homework, but when it comes down to it, we really want you to not be failing when it comes to the exam, right? It's like learning to ride a bike. How do you learn to ride a bike? Fall off a lot, right? And eventually you will learn that staying on is better, right? You'll get the muscle memory and all that balance and all those things, right? There'll be times when I'm running along and I'm holding the seat, right? And there'll be other times where I'm like, right? And let go. And then there'll be other times where I'm running alongside you and then I push you over, right? So just realize that you're going to be coming here, and if you're the kind of person that has to do it perfect the first time, you're not going to like me. So embrace the failure, right? Embrace it as a learning opportunity, and don't let it become like an emotional, right, weight on you. But homework, homework, homework. We'll talk more about lab reports and quizzes later. But if you are proficient at the homework, understand what's going on, you can do other problems like it, then I have every confidence that your minimum grade on an exam is going to be a C. Whether it's a B or an A is simply a question of what level is the proficiency at. And again, we'll talk more about that. But your best preparation for the exams is the homework. My goal on exams is to have each question be like a middle difficulty homework problem. Some of the homework problems will be easy for you. Some of them will be really hard. Others will be somewhere in between. I'm going for the somewhere in between. Okay? So I try to over-prepare you on homework. Like, homework's harder than the exams. That's one of the complaints I get from my students. Homework's so hard. I'm like, good. All right. My late policy can, I think, be summed up in a very short statement. Okay? Don't miss exams. Tomorrow, I'm going to show you the calendar. You can go look at it right now on Canvas if you want. You'll exactly when the exams are going to take place. Okay, so you know the dates. If you know you're getting married on that date, you need to tell me ahead of time, right? Life is going to happen. There's going to be emergencies. The beauty of me setting the rule is that I can break the rule, and the way we break the rule is that you have to communicate with me, right? You need to let me know before the day of the exam that something's happening. Training, the conference, whatever, the team is going out and whatever, right? Just communicate with me. I might come back and say, well, no, that's not a good excuse. But most of the time I'll be like, okay, let's work this out, okay? If you are taking the exam on any day that's not the exam day, it will be the slightly more difficult version, okay? But I can waive the 33% penalty per day kind of thing. Right? So this is incentive for you to communicate with me, right? Not freak out, right? That your boss has called a super important meeting for that day, blah, 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 right? Just talk to me. Let's see if we can't figure it out, okay? Make it fair for everybody. So I'll talk more about the exam dates and where we do them and how and why and all that kind of stuff tomorrow. I never plugged my phone in when we moved to the new building. So you can call me, I don't care. Best way to contact me is email / Canvas message. Like if you do the inbox thing on Canvas, it'll get to me. Technology in the classroom. So I love technology. I think it's great. I think you guys learn very differently from the way I was taught to learn. And so I invite you to bring, I'm going to be using an iPad, I'm going to be using my computer, I'm going to be using lots of stuff. You guys, if you want to take notes on your computers, your phones, whatever, if you want to take pictures, it's fine. I've got some things you'll see tomorrow that you won't have to do any of that if you don't want to. The one thing that about technology that kind of gets to me is the fact that people tend to get distracted with it, okay? In the sense that I've asked students to like, okay, right, like pull your phones out, look at this different thing, right? Look up this constant. And the student will pull their phone out and they'll flip it and then they'll be like, are you looking up physical constants at this point? No, what happened? Got distracted, right? Okay. Let's see. Are you willing to look at my home screen? Can I show you my home screen and you can report to it? Will you please tell people exactly how many red dots you see on my home screen? There are none. Okay. So no red dots on my home screen. Okay. Why? What does a red dot do to your brain? Right? Something's bleeding, I have to look at it. Right? Somewhere in our evolutionary past, right? Red got connected with, I must deal with it, right? And so the makers of apps that want to get your attention know this, right? And I've watched it happen. I'll tell people, grab your phone, go look this thing up, and all of a sudden everybody's on social media, right? Because something happened. Not sure what. Shakira did something. So take control of your phone. If you need help, let me help you. I can show you some ways to get it done, okay? But if you're in here, use your technology and be focused about it. Use it for physics. Use it for learning, right? If you're sitting here watching your favorite creator or something, right, and you're not paying attention to class and you're distracting somebody else, I think a crime has been committed, right? Because on the other side of these two doors, there's an entire universe for you. You can go do whatever you want with your creators, okay? What are we doing in here? We're physics, right? Don't be a distraction to somebody else. I deputize everybody in this room, right? If you are being distracted by somebody else using technology and it's not for physics, you're allowed to very politely ask them to stop, right? Hey, you're doing something that's distracting me and it's not physics. Would you mind not doing that? If they get mad at you, if they give you the middle finger, they call you names, any of that kind of stuff, let me know. I will kill them, okay? And then we'll move on. So let's, this is golden time, right? When we're together. We don't get to be together all the time. You wouldn't like that. So let's use it for what it's good for, okay? I don't know what it is about gum chewing that's always annoyed me. Excuse me. But I think it's the smacking of lips. So if you're going to chew gum, just keep your mouth closed. This thing down here. Sometimes students mean that this means you're not allowed to ask me questions. No, please ask me questions, right? Come up to me after class, ask me a question. Just realize that I will set boundaries on the kinds of questions I will ask immediately before and after class. The reason the boundaries are there is, number one, especially for homework questions, there's no time. Like a homework question usually needs more than 10 minutes, right, to get answered. Sometimes if it's a quick misunderstanding sort of thing, we can do it real quick, right? But I will judge whether or not I can answer it quickly or not, and I might tell you, hey, email me or come to grass, whatever, right? So please ask. Just realize I might say, not right now. The other thing you need to realize is prior to this class, I'm teaching physics 2B, right? So I've got to go from 2B mode into physics 2A mode, and it is a different mode, okay? And I've got to transition topics in my head, equipment sometimes, I've got to run to the bathroom, do all these different things, right? And you'll see me sometimes, I'll be talking to somebody and we're talking about not physics, right? Video game movie where they did that weekend, I might be laughing, joking, doing something else. And you'll be thinking, oh, I can go ask Mr. Balogh a homework question. He's got time now, he's just goofing off. I am not goofing off. What am I doing? I'm resetting, right? I'm trying to get my mental state back to ground zero, right? So that I can pick up and do 2A to the best of my ability. So that reset time for me is really important between the 10 minutes between classes. And so if you come up to me and ask a question, and again, I invite the question, please ask the question. Even if you're not sure you should ask, just ask it. I might say, good question, can we do that later? Don't take offense, right? I'm not like denying you. I'm just communicating that right now is not the best time, okay? So, but I can't help you if I don't know that you have a question, kind of thing. So that's what I mean by that, right? Homework questions, try not to ask before or after class. But any other question, absolutely. And I might say, hey, let's meet later, or come see me at a different time, or whatever. I wish I could program this into the computers. They won't let me do it. I want to kind of block out the 9:30 to 10:45 slot on Fridays for you. So just to communicate that on Fridays, okay, so this is the two things happening here. My office hour happens on Fridays from 7 to 12 p.m. GRASP, which is an acronym, I don't remember what it stands for anymore, is a tutorial section that opens up in this building on Fridays, where all the physics tutors come over from the tutorial center and they live here for the day, so that you don't have to compete for tutors over there, because a physics tutor that has nothing to do becomes a math tutor. Okay? Over here, they just get to be physics tutors. So GRASP is this time when all the tutors are over here. My office hour is happening in the GRASP room. I don't use my office for anything, right? And other physics teachers are holding their office hours in there as well. You have so much help in that room, right? And it's just this golden time to be able to work on homework, get help on your homework, all that kind of stuff, one-on-one kinds of things. It really, people that come to GRASP succeed. They just do, okay? Because they're getting the help and the resources that they need. I understand, Fridays are a golden day sometimes for work, other responsibilities, you got life, all that kind of stuff. That's why my office hour starts at 7, right? I'm here at 7 in the morning for people that've got 8 o'clock work and they just need some quick, 15, 20 minute, half an hour maybe of just some help to get oriented and be successful, right? Other people need longer, can come at different times of the day. This isn't the only time that tutors are available. They're available pretty much every day of the week, I think, except Saturdays. So tutors are available over in the tutorial center, right, over by the library for free. It's just that on GRASP day, on Fridays, at those times, it's concentrated goodness, concentrated physics. So I really recommend that you pencil in time for GRASP on Fridays. The worst case scenario, you go there, you're like, this isn't for me, I don't want to do this anymore, and then you don't have to worry about it, right? But usually what happens, people come and they're like, oh my gosh, this is the best thing ever. This really helps me. So I will talk about that a lot and more tomorrow. What is physics? The Far Side is a wonderful cartoon. Okay? But what do we got here? We've got 2 scientists. How do you know they're scientists? Lab coats? I thought it was because it's 2 old white guys. Yeah. So what do they got on the board? They got a bunch of math. It's squiggles and doesn't make any sense. But it's a bunch of math, right? And what does all the math equal? Equals 0, right? Okay. And I know that it's too small down here to read. But the caption says, no doubt about it, Ellington. We've mathematically expressed the purpose of the universe. Gad, how I love the thrill of scientific discovery. That's not exciting, right? Okay. That's math. It's the M word, right? It all equals 0, right? Okay. In quantum mechanics, we write everything equals 0 or 1, depending on what we're trying to do. So you have something in your brain about what either physics is. Maybe you've heard some horror stories, right? About physics 2A, that sort of thing. Maybe you're thinking it's, atomic bombs and all this kind of stuff. It's going to be a lot of math. It's going to be a lot of ideas. For this semester, there is a common theme. You guys want to guess what the common theme is? It's motion, right? Okay. It's basically things moving. How they move, why they move. It's for the kinesiology majors in here, you're going to be having a good time, okay? Because they're all about motion and getting it to work right and all that kind of stuff. So we use fancy words to describe some of these things, but these are the 5 units that we are going to cover this semester. It moves along at a pretty fast clip, and like I said, you can't skip any rungs on the ladder, right? This is a marathon. If you try to sprint, if you try to cram all the physics on one day, I'm not saying you can't pass that way. I've seen people pass that way, but in terms of success and retention and being able to pass the MCAT, physics section, all that kind of stuff, just becomes so much harder. So what you want to do is you want to schedule time into your days every day for some physics. Doesn't have to be 2 hours, even if it's just 15 minutes. Refreshing your mind on the concepts, keeping your brain in the game is really, really important. There's another problem when it comes... Okay, so let's talk about why physics is hard. What have you heard? Why is physics hard? Word problems. Oh my gosh, you're going to hate me. You are going to hate me. The universe is a word problem, by the way. Not my fault. Why is physics hard? What kind of people are in physics?
Engineers, they got let go.
Smart people, right? Geniuses. I'm not like that. This is not genius up here, okay? I'm smart, but I don't consider myself hyper intelligent. I am a geek and a nerd, and I was those things before it was cool. But here's one of the reasons physics is hard. It's got the M word in it. And what's the M word? Math. We use a lot of, this is not a math class. We're going to use a lot of math, but it's not a math class. What do I mean by that? Let's say that you decided that you can't stand this anymore and you're going to become a French literature major. And 16th century French literature. And you go to that major. Now, do you need to know French to be a successful French literature major? Maybe not. There's Google Translate, right? Okay. There's other translations that have happened. You can understand the context and the meaning and all that kind of stuff without. But would knowing French make it easier? More insightful. Yeah, all those kinds of things, right? So math is to physics like French is to the French literature major, right? You don't need math to do physics. But math as the foreign language of physics is very, very powerful. It's how we express relationship and it's all that kind of stuff. So I will not spend hardly any time teaching you math. You're supposed to know math already, right? You did some prerequisites to get here. So we're going to use trig and we're going to use a lot of algebra and things like that. It's going to be nasty and you're going to spend probably a lot of your time on the math part. I'm all about the physics part. And so if you are sitting in a situation where you're like, well, Mr. Balogh, just tell me which equation to use. You've just told me that you want to skip all of the physics, right? And you just want to do math, okay? So I'm trying to teach you, I'll get you over the hump of avoiding the physics, because the physics is painful. It's the word problem, right? So yeah, we got to get around that. Here's the other thing about physics that's a little bit different, say, from French literature. However old you are, 18 plus, how many years of French literature experience have you had? 0 to some, right? Okay. Probably not a lot, right? But if you're 18, you've had 18 years of physics experience. What do I mean by that? You've moved, right? Okay. And there are things that you think you understand about how the universe works that are flat wrong. Why is the sky blue? Why is the sky blue? What have you been told? Because the ocean's blue? I'm sure your parents are good people. But they were wrong when it came to that one, okay? Why is the ocean blue? Because the sky is blue. Okay, right? It's the other way around, right? What color's the ocean on a cloudy day? Not blue. It's gray, okay? Right? So there are pieces of knowledge stuck in your brain based on how you drive your car. If I asked you, what direction is the force on you, right? When you hit the gas, more than half of you are going to point the wrong way, okay? Because you have some sort of maybe intuition, or you have an idea about how something, when I throw it, is supposed to go, right? Because you've experienced it over and over again. It's just your explanation for that thing may be flawed. And I'm going to be pushing at those misconceptions a lot. One way I like to think about it is that students come into physics class with a bucket full of knowledge. Like you go into French literature class, you're like, here's my bucket, fill my bucket, right? Okay. In physics, you come in with a couple buckets, like, I've done physics, right? Even without thinking you've done physics, you've done a lot of physics, right? The problem is that some of the water in those buckets is dirty. So even before I can fill a bucket, what do I need to do? I need to clean the bucket, right? Okay, we need to clean the bucket up. And so you're going to be coming in here and you're like, oh, Mr. Bale, I don't understand why I'm getting it all wrong. I was like, because you've done it this way for how many years you've been alive, and here I am telling you that it's actually this way. And so not only you must unlearn what you have learned, right? Okay, it's like I've got to fight against a lifetime of experience, right, to help you come to see what the universe is actually doing under the covers. Okay, so that's another reason physics can be pretty hard, is because you're trying to bring to bear things that you think you know that could be wrong. All right, where are we at? We are doing good. Let's get started. There's a lot of information that I know you probably, okay, let me ask the question this way. Does anybody have a question they need to ask right now? Otherwise, they're just not going to be able to sleep tonight about the class, about anything. You have plenty of time to ask, but just want to make sure you can walk out of this room going, oh, okay, maybe, right? Tomorrow, we have 2 hours and 50 minutes together in the lab. We're going to go over a lot more information in depth, okay? And you'll be able to ask tons of questions. I'll answer, right? We'll try to get everything squared away tomorrow, right? But let's do some physics. Let's do what it said here on the tin, so to speak, right? And we'll start with chapter 1. Of course, everybody has read chapter 1, is ready to go, right? No, don't even know where the book is, Mr. Balogh, right? Because I'll tell you about it tomorrow. So chapter 1 is I don't consider it a physics chapter. It's a math chapter. It's a kind of a primer for getting ready to go, right, mathematically in the course. So I do apologize. Chapter 1 is a bunch of mathy stuff. I'm actually going to break chapter 1 up a little bit. So like we're going to have a kind of a part 1 to chapter 1, and then we're going to go to chapter 2, and then we're going to come back to chapter 1, okay, to finish up. Just because I prefer, instead of just dumping a bunch of math on you right at the get-go, I'd rather give you enough math so that we can do chapter 2, and then we'll come back, learn some more math so that we can do chapter 3, so on and so forth. So it'll be a little bit out of order, right? But we got to go over units, and we got to talk about trig, and we got to talk about this thing called vectors. Vectors we're going to handle on the other side of chapter 2 because they really come up as a part of chapter 3, okay? But let's really quickly, this is probably some knowledge that you already have, okay? But there are really 2 kinds of unit systems in the world, okay? Does anybody know what this is? This is a meter stick. How do you know it's a meter stick? It's a meter long. It's in meters, centimeters, millimeters, and there's no yards on the back of it. You know how hard it is to find a non-yardless stick in the United States of America, right? Okay. So what 2 unit systems exist? There is the perfect unit system, and then there's everything else. Okay. Now, the unfortunate truth that you need to understand or accept is that the United States has been on the metric system for at least 60 years. You're like, Mr. Balogh, I got news for you. My car still says miles per hour, right? The signs still say miles, right? What's an inch? It's like 2.2 centimeters. What's a mile?
1.9 kilometers.
Okay. The foot, the inch. What's an ounce? All of these units that we use in the so-called imperial system of units, we're still calling it by the British name, right? We were kicking them out. We threw their tea in the harbor. We didn't get rid of their unit system. We are idiots. So all of those units, ounces, inches, feet, mile, everything is defined by the metric equivalent. The metric system is defined on universal constants like the speed of light, okay? Things that don't change no matter where you go in the universe. But the imperial system of units is defined by the metric system and has been for the last 60 years, right? So we're actually using the metric system in the United States of America. It's just the everyday usage is in this other system of units, which I don't understand. How many centimeters are there in a meter? What does centi mean? It means 100. So when you say the word centimeter, it means 100 meters, right? How many meters are there in a kilometer or a kilometer? 1,000, because kilo means 1,000, right? So if I have, give me a number. Give me a 2-digit number. 20? Give me another 2-digit number. 42. How many centimeters are there in 20.42 meters? 2,042. What just happened? You just moved the decimal point, right? Because in the metric system, everything is a power of 10. Wonder where we got that idea. Right? Okay? All right. How many inches are there in 20.42 feet? How many ounces are there in 20.42 pounds? What's the problem? You can't multiply by 12 or 16, right? Those just aren't easy decimal point things to move around, right? So in science, engineers break this a little bit. That's difficulty. But in science, we use the metric system. It's just easier. Now, it's a little bit rough for us here in America because we don't really have an idea or a concept of what a kilometer is, right? If you say, hey, we have to go walk a mile, you've got some idea of what that means, right? But walking a kilometer, is that longer? Is it shorter? Like, right? Okay, it's shorter than a mile, right? But it's about 2/3 of a mile. But it's like, we don't have, if you were born and raised in the United States, you grew up not using the metric system as an everyday part of life, right? So we do have to do a lot of conversions back and forth, okay? And so how do we convert between units? Oh, by the way, here's a picture of all the countries that use the English system of units in gray. Everything in green uses metric. Myanmar is now called Burma, isn't it? Or it used to be called Burma, now it's called Myanmar. I think we're a little behind, right? A little bit behind, okay? So how do we convert? How do we go from 20.42 feet to meters? I want to find that number in meters. How do I do that? Hey Siri, how many meters are there in 20.42 feet? 6.22. That's what Siri says. That's how you do it, right? You just ask the AIs, right? They'll do it for us. Sure, right? You're not allowed to do that on the exam. And if you're ever caught without your phone or anything like that, as hard as that may be to think about, right? How would we go, like how did Siri do it? See, this is the thing about science and technology. We're not content with just getting the answer. We got to know where it came from and why it happened, right? So how did Siri do it? Okay, so we need something called a conversion factor. Something that tells us like what 1 foot is in meters or vice versa. So if you go look up some conversion factors. Do I have any here? Of course not. Where are all my vectors? Where are all my... Pages fell out. There we go. 1 meter is equal to 3.281 feet. But 1 foot is also equal to 0.3048 meters. Uh-oh. Now what? I've got 2 conversion factors. What do I do?
Don't you cross multiply?
Okay, yeah, there's a lot of like stress and angst that comes up over, do I multiply? Do I divide? What do I do? The answer is you always multiply. There is no such thing as division. These are not the droids you are looking for. Okay? What do I mean there's no such thing as division? What is division? It's multiplication of a fraction, right? Division in and of itself as an operation doesn't exist. Same thing with subtraction. What is subtraction? Adding negative numbers. You unlock those superpowers, you can do anything because there's only 2 things you have to remember to do, right? Addition and multiplication. So we are going to multiply, right? We're going to multiply. And what we're going to do is we are going to multiply by a conversion factor, a fraction. This is where I'm a little cheating a little bit, right? Okay, because we'll end up dividing or doing something, okay? However, we are not going to guess as to what the conversion factor and where they go are going to be. We're going to let the units do the talking. What's the unit we want to get rid of? Feet. If feet's in the numerator and I want to get rid of it, where do I put it in my factor? In the denominator, right? Because you got the same thing up top and you got the same thing in the bottom, they are going to cancel each other out, right? Okay, so we know feet goes on the bottom. Ideally, what would we want to have on the top? Meters. Do we have a conversion factor that goes directly from feet to meters? Yes, we've got 2. Which one do we use? You see this line in the room right here? Okay? Everybody on this side is going to be the top conversion factor. Get your calculators out, okay? Everybody on this side of the line is going to be the bottom conversion factor. We will write down both of these. So if we're using the top conversion factor, what do you write down in the numerator? In the numerator next to the meters, using the top conversion factor, what do you write down? 1. And then what do you put in front of the feet? 3.281. Okay, if you are doing the bottom conversion factor, then this is going to be 20.42 feet. You're going to have feet in the bottom. You're going to have meters on top. What number are you going to put for the meters? 0.3048. And what are you going to put for the feet? 1. Okay, so I assigned you a calculation to do. Do it, show your neighbor, see if you agree on the answer, and then wait for me to call it to ask you for it. All right, this half of the room, what did you get? 6.22? Do I hear yes, 6.22? You agree? Okay, excellent. That's what Siri said. All right, this side of the room, what did you get? 6.22. Oh my gosh, what just happened? It's the same thing. Don't get caught up in whether you have to like multiply or divide. Concentrate on where you've got to put the conversion factors to get the things to cancel out that you want to cancel out and get the thing that you want. And you can build these things up. Let's do a number of seconds in a year. Okay? So, what we want to know is what? What are we looking for? Seconds, right? That's what we want to end up, isn't it? But what are we starting with? 1 year. Okay. So if I've got 1 year, can I go directly from years to seconds? No. Is there something else, another section of time that is a little bit easier to get to? Probably days, right? So if I put years on the bottom and I put days on the top, for every 1 year, how many days are there? 365.25, because there's quarter year and leap year and blah, blah, blah. Okay? So, now, can I go straight to seconds? What am I going to put on the bottom? What do I have to get rid of? I got to get rid of days now, don't I? Because I took care of the years. Now I'm going to take care of the days. And is there like a easier section of time I can go from days to something? Hours maybe. So for every 1 day, how many hours? 24 hours. Okay. Now I am going to cheat a little bit. I'm going to go from hours to seconds. I'm getting tired of writing stuff. Okay. In 1 hour, how many seconds are there? Careful. It's 60 times 60, right? There's 60 minutes in an hour and 60 seconds in a minute, right? So what's 6 times 6? 36, and then you've got to add 2 zeros. I was getting lazy. Okay, so now do the conversion factors. Are they working out? Are they lining up? Yeah, right. See how I've canceled years, days, hours. What am I left with? Seconds. So in my calculator, what do I have to do? I have to do a bunch of multiplications, right? Okay. So whenever you are up against a convert, and I don't actually care what the answer is here. For the people that want to know, it's 3.2 times 10 to the 7 seconds. So the point I'm trying to make here is don't be afraid of conversion factor. We're going to use them all the time. And the safe thing in all of physics, science really, but especially in physics, is to always use the metric system and get things into their standard SI unit. The SI unit system is the metric system. And so by standard units, I mean things like time. If you're given a time period in hours or minutes, those are not standard time units in the metric system. What's the standard metric time unit? Seconds, right? So you're going to convert into seconds, no matter what the thing is, right? Distances, put those into meters. Meters is the default standard unit in the metric system. Meters, seconds. When it comes to weight, or more correctly mass, this one gets a little bit weird. Kilograms is the standard SI unit system unit. It's not grams, it's kilograms. And what does kilo mean? It means 1,000. Here's a little hack for this course. Memorize. I don't ask you to memorize anything. You don't have to memorize this. You can put this on your summary sheet if you want, okay? But if you have kilo, mega, giga going up, and centi, milli, micro, and nano going down, if you know what those prefixes mean, you are going to grease the wheels so well that you are just going to be going fast, okay? To not have to stop and look up what those powers of 10s are is really going to pay dividends, especially in physics 2b, right? What's giga? It's 10 to the 9. It's 1 billion. Okay, what's mega? 10 to the 6. What's kilo? 10 to the 3. Centi? It's 10 to the 2. That one sneaks in just because of centimeters, right? Milli, 10 to the negative 3 micro, 10 to the minus 6, and nano, 10 to the minus 9. So really you can see that we're just counting by threes here, right? With the exception of centi. There are others, hepta, deco, there's a bunch of little things in there, right? But they're really not that important. We don't use them that often. These are the ones that are used like constantly. And so if you see 3.67 kilometers and you want to convert that into meters, what do? For every 1 kilometer, how many meters are there? What does kilo mean? 10 to the 3. And so a lot of times you will see me not do this. I'll just write 3.67 times 10 to the 3 meters. Where did the K go? It means times 10 to the 3, right? So if I had 3.67 megameters, how many meters is it? 3.67 times 10 to the 6 meters, right? That's a really quick conversion factor. You can do it the long way, but really just take the prefix and write out its power of 10 and you're done. So you're going to want to have all of those things on board. I will see you tomorrow. I'll finish up chapter 1 on Thursday, do some more stuff with it, and then we'll get into chapter 2 also. But tomorrow, be there, right, for the class, the section you're trying to get into. We'll spend a lot of time on the homework system and all of those things and try to get all of your questions answered and get you registered in the course. See you then.